All right, so let's say the price P and quantity sold X of pens obeys this equation. So price equals -1 over 100, X plus 1. And let's see here, let's ask a question. So let's say part A, let's express the revenue, and I'll call that R, as a function of X. All right, so part A, we want to express the revenue R as a function of X. So R of X. Now, anytime you're dealing with price and quantity sold or quantity demanded, if you're thinking about a business here, your revenue is always going to be how many you sell times the price at which you sell them at. So it's going to be P times X. Think of it as if you sold a pen for $1 and you sold 10 of them, then your revenue was $10. So revenue is always going to be price times quantity sold. And in this case, we know that P is equal to -1 over 100 X plus 1. And that's going in for P, so we still have an X on the outside. And I'll go ahead and simplify that, distribute that X in. -1 over 100 X squared plus X there. So representing the revenue as a function of X, we can do that. And then for part B, this isn't really a question I would be too interested in on this example myself, but I saw it on the homework, so I want to do it here as well. Find the domain of R of X. And the idea here is, well, we know it's a quadratic function, so I'm just going to put a random graph up here. We know it's a quadratic function, and we know in front of the X squared we have a negative, so maybe it looks something like this. I'm not sure exactly what it looks like, but maybe it looks something like this. And so the idea is, because this is the revenue function, there's no company out there that's going to make a product or sell a product if their revenue is negative. So we don't really want any of this stuff underneath the x-axis. We wouldn't want the revenue to be negative. So what part B here is really asking is, okay, when would we want to sell these pens? When would we have at least a positive, or the worst case scenario, 0 for revenue? And so really all we need to do there is figure out those x-intercepts. And to figure out x-intercepts, you set the function equal to 0. And let's see here, if we do that, well, in order to solve for x, we could factor out an x. That'll leave us with -1 over 100 times x plus 1. And so one of the intercepts is 0, so immediately my graph is wrong. That's okay. That graph is just there to explain why we need the intercepts. And the other one is going to be, oops, I put a 0 there. That should be an x. Let's change that. So 0 equals x, and then 0 equals -100x plus 1. I'm going to add the 1 over 100x to the other side, leave the 1 on the right-hand side, and then multiply both sides by 100 to get the other intercepts. So 2 intercepts there, 1 at 0, 1 at 100. So really what my graph should look like is more so something like this. Not drawn well, but that's okay. So we have x-intercepts at 0 and 100 there. So that's going to be the domain of this function. Because this function represents revenue, the company would be better off not selling the pens if they're going to sell, obviously less than 0, but also more than 100. Maybe once you pass 100, maybe the costs of selling those, maybe there's something else going on there in terms of the revenue. So let's see here. So the domain here, it asks for a set notation, I noticed on the homework, so I'll write it in set notation. So x such that 0 is less than or equal to x is less than or equal to 100 there for the domain of this function. And let's see here, I'm about to lose my function up there. Let me pull it down a little bit here. Let me write down part C. Part C, let's see here, I want to know what amount of pens sold will maximize revenue. I'll just sneak that in here. What amount of pens sold will maximize revenue? So we're trying to find the local maximum here for this revenue. We can see it on my picture above. This is definitely going to have a high point here. That's a local maximum. But I want to know specifically on part C, what amount of pens sold will actually maximize the revenue. And so I'm going to rewrite my revenue equation, then I'll move this all up. So R of X is equal to, it was negative 1 over 100 X squared plus X. So I'm going to go ahead and move this up. And now I can go ahead and complete the square. So I'm going to factor out the negative 1 over 100. That'll leave me with X squared minus 100X. And nothing on the outside, that's okay, not a big deal. So in front of the X, I have a negative 100. Can divide that by 2 and square it. Negative 100 over 2 is negative 50. I'm going to square that. I'm also going to put my reminder there. I got a negative 50 after I divided by 2. Negative 50 squared is 25 with 2 zeros. So I'm going to add 2,500 to the inside here. Keep in mind, I have a negative 1 over 100 on the outside. I'll do that work off to the side as well. So negative 1 over 100 times 2,500. Okay, a bunch of zeros cancel there. So that gives me a negative 25. So really when I added that 2,500 to the inside of the parentheses, I really subtracted 25. I need to add 25 in order to balance that out. And let's see here. So, okay, now I can go ahead and factor. I have my X minus 50. Quantity squared plus 25. Part C here wanted to know what amount of pens sold will maximize revenue. Well, the amount of pens, that was related to the X value. So that's going to give me X equals 50 pens there, or whatever the units were. Let's say it was just individual pens. And then let's go ahead and tack some more stuff on here. Let's say part D, I'll put right here. Part D, what is the max revenue? Well, we already completed the square, so we can see that as well. This graph is being moved up 25, so the max revenue is going to be 25. I don't think I put a unit on this earlier, so whatever, dollars or whatever it might be. 25 there is how much it goes up on the y-axis, or the r-axis, I should say. And I'm going to tack on one extra question here as well. So how much should each pen cost in order to maximize revenue? Okay, so I want to know how much should each pen cost. So I want to know the price of the pen that's going to maximize revenue. And it's up above now. I'll just rewrite the price function was negative 1 over 100 x plus 1. And we figured out on part C, we had figured out that x was going to equal 50 here in order to maximize revenue. So let's go ahead and plug that in. Negative 1 over 100 times 50 plus 1. Negative 1 over 100 times 50, that's negative 1/2, plus 1 is positive 1/2. So it looks like, if that was in dollars, maybe then 50 cents, or the price is going to be 1/2, whatever the unit is for the money there. Let's see here. I guess one general thing I'll say, just silliness. Obviously, I made up this example. I made up the numbers here. This is probably a pretty small company if they're only selling 50 pens and making $25, and each pen costs, 50 cents. But not the point of the problem. Just a word problem with completing the square to get more practice.